All right, so we see these things all the time, right? These massive monuments of rock and ice just scraping the sky. But have you ever really truly stopped to think about how they got there? Well, today we're going to take a journey from those incredible peaks all the way down into the fiery heart of our planet to figure out exactly how a mountain gets made.
So you look at a mountain and think, how in the world did that get here? It seems like a simple question, right? But the answer? Oh, the answer is epic. It spans whole continents and millions of years. These giants didn't just pop up overnight. Nope, they were forged by forces so powerful it's hard to even imagine in this incredible super slow-motion drama.
Okay, so before we can talk about how they're built, we kind of need to be on the same page. What is a mountain? I mean, what's the actual difference between a mountain and, a really, really big hill?
And the key word here is prominently. It rises prominently. See, it's not just about how high it is from sea level, it's all about how much it towers over the land right around it. We're talking steep slopes, rugged peaks, that whole dramatic silhouette against the sky. That's a mountain.
All right, now for the fun part, the blueprints. Geologists have figured out there are basically 4 main ways the Earth builds mountains. You can think of them like 4 different recipes for making these absolute giants. First up, we have folding. And the best way to picture this is to imagine you have a rug on the floor. Now start pushing both ends toward the middle. What happens? The rug has to go somewhere, so it bunches up into these ripples and folds, right? Well, that's exactly what happens on a planetary scale when 2 massive tectonic plates smash into each other. The crust just buckles and crumples upwards.
And the number one example of this? The Himalayas, for sure. Get this, the very top of Mount Everest is made of limestone that has fossils of sea creatures in it. That rock used to be at the bottom of the ocean. It got shoved up there by this massive, slow-motion car crash between the Indian and Eurasian plates. And the craziest part? It's still happening. The Himalayas are still getting taller, even today.
Okay, method number 2, faulting. This time, instead of the crust bending like a rug, imagine it's more like a giant, brittle chocolate bar. If you put enough pressure on it, it doesn't bend. It just snaps. Those cracks are called faults, and along those faults, huge blocks of rock can get pushed straight up, creating these mountains that often have one really steep, sheer side.
A perfect place to see this in action is the Sierra Nevada in the US. That whole mountain range is basically one gigantic block of the Earth's crust that got tilted and shoved upwards. It's what gives it that famous, incredibly steep eastern side that just drops right down into the valley.
So our third method is totally different. We're not pushing up old rock here, we're building something brand new from the inside out. This is all about volcanoes. You have molten rock, magma, that comes up from deep inside the Earth, erupts, cools down, and hardens. And it just keeps doing that, building the mountain up layer by fiery layer.
And of course, the poster child for this has to be Mount Fuji in Japan, right? I mean, that perfectly symmetrical cone, it's just a work of art. It's a masterpiece built over thousands of years, just layer after layer of lava and ash. Okay, our last blueprint is kind of the opposite of the others. It's not about building up, it's about carving down. Think of a sculptor. They start with a big block of marble and they chip away everything that isn't the statue. Well, here, the Earth lifts up a huge high plateau. Then, for thousands, millions of years, things like rivers and glaciers act like the sculpture's chisel, carving away all the softer rock and leaving behind just the tough, hard stuff as mountain peaks.
And a really cool example of this are the Catskills in the US. What's so interesting is that they weren't formed by plates crashing together. Nope, they're actually the leftovers of an old plateau that's been carved up and sculpted over eons by water and ice.
So there you have it, 4 incredible ways to build a mountain. But that begs a pretty big question, right? What's the engine behind all this? Where does the power come from to literally fold continents in half or shatter the planet's crust?
Well, the answer is one of the biggest ideas in all of science, really, plate tectonics. This theory completely changed how we see our own planet. The ground we're standing on, it's not one solid piece. It's actually a collection of huge plates floating on a layer of semi-molten rock, and they are constantly moving, crashing, and scraping past each other. And that is the engine that drives mountain building.
Let's go back to the Himalayas to really see how this works. Picture this. For millions of years, the piece of crust that India is on was just drifting north. Then, bam! It slams right into the Eurasian plate. Now, since both plates were thick, continental crust, neither one wanted to sink. They were just too buoyant. So, with nowhere to go, the only direction was up. The land just buckled, folded, and shot skyward, creating the roof of the world.
But here's the thing, not all plate collisions are the same. It depends on what's crashing into what. So, if you have a heavy ocean plate hitting a lighter continental plate, the ocean plate gets forced underneath. That's called subduction. And as it dives down, it melts and creates a ton of magma, which then fuels huge volcanic mountain ranges like the Andes. And what if two ocean plates collide? Well, one of them dives under the other, and you get a chain of volcanic islands, just like, you guessed it, Japan.
Okay, so now we know how they're built. But so what? Why should we care? Well, it turns out mountains are way more than just pretty scenery. They are absolutely vital systems for all life on Earth.
I mean, their influence is just massive. For one, they shape our weather, acting like giant walls that block wind. They're also the world's water towers. All that snow and ice melts and provides fresh water for literally billions of people. Because of all the different elevations, they create all these unique little habitats, so they're hotspots for wildlife. And, just on a human level, they've always been these incredible sources of awe and inspiration for us.
And all this leaves us with a really cool final thought to chew on. This whole process, this mountain building, it isn't over. It's happening right now as we speak. It's just so slow we can't see it. The face of our planet is always changing. So, as these plates keep doing their slow, relentless dance, it really makes you wonder, where is the Earth's next great mountain range going to be?